Hello, my name is Kumar Guru Analik L. Sridhar. My metric card number is 10TGL22F1021. Today I am going to present it about internal combustion engine, ICE, valve timing. An internal combustion engine is type of heat engine that converts chemical energy stored in fuel into mechanical energy through combustion within the engine is commonly used in vehicles, generators and various machines. Internal combustion engine typically consists of cylinders where fuel and air are mixed ignition and burned to produce high pressure gases, which they drive pistons up and down. This motion is converted into rotational motion, powering the vehicle or machine. They come in various types, including gasoline and diesel engines, each with unique combustion process and efficiency. This is a four-stroke engine which is a four-component intake, compression, power and exhaust. Valve timing diagram for four-stroke engine. Valve timing refers to the precise coordination of the opening and closing of intake and exhaust valve within the engine cylinders. It is crucial for optimize engine performance, fuel efficiency and emissions control. Timing is usually controlled by the camshaft, which is synchronized with the crankshaft to ensure valve open and close at the right moment in the engine cycles. Adjusting valve timing can improve power delivery, fuel economy and overall engine efficiency. This is valve diagram of four-stroke petrol engine. In a typical petrol engine, the valve timing diagram illustrates the opening and closing timing of the intake and exhaust valve relative to the piston's position of crankshaft angle during the four-stroke cycle. Here is a simplified explanation of a typical petrol engine valve timing diagram. Number 1. Intake valve opening. The intake valve opens as a piston approaches top dead center on the exhaust stroke, allowing the air-fuel mixture to enter the cylinder. Number 2. Intake valve closing. The intake valve closes after the piston reaches bottom dead center BDC on the intake stroke, sealing the combustion chamber to facilitate compression. Number 3. Exhaust valve opening. The exhaust valve opens near the end of the power stroke as a piston approaches to release exhaust gases from the cylinder. Number 4. Exhaust valve closing. The exhaust valve closes after the piston reaches top dead center on the exhaust stroke, sealing the combustion chamber for the next intake stroke. These timing are optimized for engine performance, efficiency and emission control. The valve timing diagram helps engineer analyze and adjust this timing for specific engine requirements. Next is valve timing of four-stroke diesel engine. In a diesel engine, the valve timing diagram follows a similar principle to that of a petrol engine, but with some variation due to the different combustion process. Here a simplified explanation. Intake valve opening. The intake valve opens as a piston approaches the top dead center on the exhaust stroke, allowing air to enter the cylinder. In some diesel engines, the intake valve may open slightly before top dead center to ensure sufficient time for air induction. Number 2. Intake valve closing. The intake valve closes after the piston reaches bottom dead center on the intake stroke, sealing the combustion chamber for the compression. In the diesel engine, the intake valve closing timing may vary depending on factors such as engine speed and load. Number 3. Injection timing. Instead of using spark plug, diesel engines inject fuel direction into the cylinder near the end of the compression stroke, and engine performance it typically occurs shortly before or after top dead center on the compression stroke. Number 4. Exhaust valve opening. The exhaust valve opens near the end of the power stroke as the piston approaches bottom dead center to allow the explosion of exhaust gases from the cylinder. Number 5. Exhaust valve closing. The exhaust valve closes after the piston reaches top dead center on the exhaust stroke, sealing the combustion chamber for the next intake stroke. These timings are optimized to ensure efficient combustion power delivery and emissions control in diesel engines. The valve timing diagram aids engineer in fine-tuning this timing for optional engine performance under various operating conditions. Conclusion. Valve timing plays a critical role in the operation and performance of internal combustion engine. It ensures the precise coordination of intake and exhaust valve opening and closing with the piston position during each stroke of engine cycle. Proper valve timing optimization leads to improved engine efficiency, power delivery, fuel economy, and emission control. Thank you.